Thank you. Yeah, hi. Thanks, Chris, for inviting me to talk to you. I'm excited to talk about the program that I've been working on, the Nitrogen Optimization Pilot Program. And before I get into it, I'm going to start off by saying we have the next grant cycle, cycle 3 of this program becoming available. So we will have those applications available coming up in October. So an extra reason to pay attention. We've got opportunity for you to be involved in this program. So program details, as Chris mentioned, it's a program that's funded by the state government, the Department of Ag and Trade Consumer Protection, and it's the Nitrogen Optimization Pilot Program. And it's offering a maximum grant award amount of $40,000 to agricultural producers to conduct 2-year on-farm research projects. So these are really farmer-driven projects. The farmers work with agronomists or other collaborators to conduct their own on-farm research, which is what makes it really unique. It's not just researchers plopping research trials on farm fields. It's actually farmer driven, which is one of my favorite parts about the program. And then it's in partnership with UW for data interpretation. That's where I come in. I'm the research director for the program, so I kind of serve as like a consultant for helping folks get the trials set up on their fields, work out how we can make the trials work for them so that they're getting the most valuable information and also that UW is getting the most valuable information that then we can use to build our databases. And I also do the data analysis for the project, so I'll get you your results from your trials once they wrap up. And kind of help and see what else we can piece out from the data just by looking at it together. And the main goal of the program is just to enhance the understanding of nitrogen. I think we all wanna figure out how we can better utilize the nitrogen that we're putting out, not only to improve producer bottom lines, but also so that we're mitigating some of those environmental risks with over-application of nitrogen. So overall, the goal is just to make the most of what we're putting out on our fields. And just kind of the bare bones of the trials, they must include 4 nitrogen rates replicated 4 times, and this is required resampling and record keeping so that we're able to get the most out of the trials that are going on and that we have all the background information from surveys and records from in-season management. So we have everything we need to go with the data that's actually collected from the trials. So, I say 4 rates, 4 replications. What does that actually mean? So this is an example of just about the simplest project you could get. And I know you might look at it and think, oh, that doesn't look so simple, but it is. So it's just the 4 nitrogen rates, so including a 0 nitrogen rate. And the reason we have that is that so that we're able to figure out how much nitrogen the soil is actually supplying on its own. If we grow a crop, we don't apply any nitrogen, what do we get from that crop just from what the soil is supplying? And that just really serves as a good baseline. So we're able to assess the true value of the fertilizer we're putting out by kind of comparing it with that control. So in a field design like this, we have those rates occurring across the field 4 times, and they're kind of grouped together in what we call in statistics blocks. And the cool thing about this experimental design is that by blocking the nitrogen rates, then when I do the statistical analysis, I include that in the model, and then we know whether any differences we see in the rates are due to the rates themselves or whether it's just due to kind of the location on the field. So even though we know farm fields are variable, we know there's a lot of variability just in research and nitrogen research in general. By doing this kind of experimental design and using this approach, we're able to kind of better figure out what those differences are due to and if it's actually due to the nitrogen rates themselves. So building a project, so that was kind of just the basics of a nitrogen rate trial and kind of the most basic project that we can have in NOPP. But a lot of farmers want to go above and beyond, and they want to add another question. How do my rates compare maybe with and without a cover crop or with and without manure, kind of as Chris was mentioning? So the first thing to building a project, and this kind of forms into what you'd put on your application, is coming up with that research question. So for example, one group of farmers were wondering, how does cover crop termination time affect optimum nitrogen rate? When that cover crop gets larger, do I need to add more nitrogen? Do I need less nitrogen? Do I need more nitrogen up front? So there's a lot of questions that go with that, but that's the kind of the overarching question is how does that timing affect nitrogen cycling in my field? The next step is designing the project. So for this specific question, we do a nitrogen rate trial, like I showed in that last slide, but a split plot design. So you'd have all those rates replicated with an early terminated cover crop and then with a late terminated cover crop so that we're able to make that comparison. And that field design can get a little tricky, but folks who are interested in doing this work with me and we figure out something that's going to work with your equipment on your field. Next is determining collaborators. That's another really cool thing about this program. Within that grant, you're able to use some of that money to partner with an agronomist or a different collaborator to help kind of take care of some of that, any of the sampling or the work that goes into it, and also help on the administrative side, and their time can be compensated for through that grant. So this specific example, the producer worked with his producer-led watershed group. So it was a group of producers that kind of they could lean on and have that sense of community around this project. And also the county conservation planner, which helped a lot with the administrative side of things and kind of administering funds. Then the detailed project plan. So many things to think about with these projects, right? What do I want to sample? How do I want to sample? When do I want to sample? So many things to think about. And that's kind of also part of why I'm here to help you think through that so that we're able to get the best data possible. And while there's so many things to think about, again, there's just the basis of we want to manage nitrogen better. That's the basis of this program. So one of the things that we're really interested in finding out from grantees of this program is how are nitrogen management decisions being made? So a question that we asked on a survey that we sent to all of the grantees, and this is word for word what we asked on the survey, it was an open-ended question. Do you use any decision support tools for nitrogen management? We wanted to find how are people making these decisions. 86% said yes, 14% said no. And of that 86%, we had kind of a wide array of different tools that folks were using. 41% said UW Rex and SNAP Plus, using their nutrient management plans to make these decisions. Maybe they just said that because the UW logo was on the survey, and it's a debt cap funded program. But I do think a lot of folks use that to make their decisions. And then we have other factors playing into it too. Soil tests, tissue tests, some other nitrogen management tools, online or that their agronomists use that are on the market. So we have a pretty interesting spread of what folks are using to make these decisions. And I hope that through this program and through this push for on-farm research, maybe 5 years from now, we'll have a little wedge that says from conducting my own nitrogen rate trials. Maybe that'll be 100%. That would be amazing. And I'm just hoping to push that and that can then be used as a nitrogen management support tool. So what do these projects actually look like data-wise? What can we get from these? What can grantees expect to get back? So this is an example of a nitrogen rate trial similar to that first field design I showed you. This is up in Barron County, and this was an agronomist that worked with a group of producers, and they conducted nitrogen rate trials on 3 different fields. So from most of these, we're going to get a nitrogen response curve. I will admit they don't always look this perfect. This is a perfect quadratic plateau. I would love to see that coming from every field. But as we know, these things are variable. Nitrogen response isn't always this clean. Sometimes we get a straight line. Sometimes we get weird curves. But this is kind of what most of them look like. So on our x-axis, we have nitrogen fertilizer rate. Those are those different rates that are put out on the field kind of as the treatments, those different strips. And then on our y-axis, we have corn yield in bushels per acre. So you can see generally we start at that 0 nitrogen rate requirement of the program. As the nitrogen rate increases, corn yield increases until it gets to a certain point. And that point is what we call the agronomic optimum nitrogen rate, or AONR. So in this specific field, it was 81 pounds of nitrogen per acre. After that point, we didn't see any increase in yield. And using statistics and using kind of the values from that curve that we get before it goes flat, we can also calculate the economic optimum nitrogen rate. So this takes into account the price of fertilizer, what we're selling corn for, and it's the rate where you're not getting any more return on your investment by putting out more nitrogen. I like to say the most bang for your buck for your fertilizer at this rate. So that economic optimum nitrogen rate on this field is 76 pounds per acre, so just a little less than the agronomic. Like I said before, we also have all of the field history. So we know if this field had a history of manure, we know what the previous crop was, we know what the yield potential of the soil is. So from those, we can use our university nutrient application guidelines at A2809. I'm sure that's burned into everyone's mind, and that we've got that nitrogen application table. So from that information that we have about the field, we know what our university recommendation would have been for this field. So for this specific site, it was 120 pounds of nitrogen per acre. So you compare that, and that university recommendation also takes into account the cost of fertilizer and corn price, that corn to nitrogen price ratio. So if we compare that to our EONR, we're off by a decent amount, but we're in the ballpark. So from these from the results from these trials, we're able to gain all of this great information. So then there's those projects that I mentioned before that layered another element on top of the nitrogen rate trial. So this is an example that I used before with that question. They're wondering about cover crop termination timing, and this was a group of producers in Dunn County. So if we look at the results from their trial, so again, they had that early terminated cover crop, they had that late terminated cover crop. I think the early was terminated in like the 3rd of May and the late was like the 30th of May, so about a month spread on those. And you can see at that lower, again, same thing, x-axis here, we've got nitrogen rate, y-axis, we've got corn yield. And at that lowest nitrogen rate, the 0, which is required by the program, we can see that there's a pretty big yield difference between that early terminated cover and the late terminated cover. We see a yield hit at the later terminated cover where it put on a little more biomass. But as we increase that nitrogen rate at about 100 pounds per acre, that evened out. So we didn't see that negative effect anymore. So we can see the corn was a little behind from that nitrogen, but eventually it caught up once we applied that nitrogen at those higher rates. So another example of how we can use, even though we weren't able, because we don't see the perfect quadratic plateau here, we weren't able to get that economic optimum and that agronomic optimum, we can still make a great comparison and gain really valuable information from this field. So another example of this is a soil comparison trial. This was down in Jefferson County. So this farmer had noticed he had 2 areas of the field that super different soil types, but he'd been managing them the same. And he's thinking maybe he can manage nitrogen a little differently on this one area of the field that was higher up on a slope. That was a lighter soil compared to the lower area of the field, which is a heavier soil, higher organic matter. And he's wondering if the nitrogen needs for that crop grown on those 2 different soils would be different. So first, if we look at the soil data here, we had that coarser field area and that finer field area. Pretty big difference in organic matter, pretty big difference in cation exchange capacity. So kind of what he was expecting to see there from the soil results when those were sampled kind of as 2 different zones. And then if we look at that soil nitrate, so this is just in the first foot of the soil profile, sampled at 3 different times, pre-plant, pre-side dress, and post-harvest, because you want to see how much nitrogen was left over after that crop was removed. So you can see, especially early on in the season, pretty big difference in soil nitrate between those 2 field areas, between that coarser soil and that finer soil. So theoretically, as that once that corn is planted, there would be a different amount in available nitrogen for that plant. So, and I think the yield curve kind of tells that story. So again, x-axis nitrogen rate, y-axis yield. And here we've got those 2 different soil textures represented by those 2 different lines. So that red line is that finer soil that had a little higher nitrogen content, higher organic matter. And the gray line is that coarser soil. So you can see all across all nitrogen rates that field with the finer soil yielded higher, and even at those higher rates, they never really equaled out. So it was more than just a nitrogen issue because they stayed kind of spread apart. You can just see that finer texture soil had a higher yield potential. It didn't even reach the economic optimum nitrogen rate. So we can see that it's maybe not as worthwhile to put as much fertilizer on that coarser textured soil because the yield potential is just so much less. And that's a good example of that. And I think that kind of gets the ball rolling in a lot of people's head. Oh, maybe I can manage my fields. We're seeing it on this field, but I think the same thing might be true across the farm. So now building off of, I'm sure what you've all been waiting for, building off of Stephen's presentation, we also had a biological trial. And we had quite a few biological trials, I think 4 or 5 in the first cycle of NOPP, looking at a variety of different products. But I think farmers altogether, agronomists had the same question. We're seeing these things on the market. People are using them and saying they work, but how can we actually see if these are working by comparing it to a control? So this farmer used this biological seed treatment, and he did a really complex split plot design. He did 8 nitrogen rates. He really wanted to see if it worked or not. 8 nitrogen rates, and then with and without that biological trial, what we call a split plot design, so you can make those comparisons. And I will say this is the results from that trial in Green Lake County, but there is pretty similar across the board last year. We saw pretty similar things across the board for all of the biological products that were used. Again, it was a super dry year. And these NOPP projects are 2-year projects. So we'll see what we see this year, kind of, different end of the extreme. If we get 2-year projects, we're gonna have a drought year, and we're gonna have a wet spring that turns into a dry summer and fall. So, we've got all the extremes here, represented in these 2 years of data. But again, same thing, our yield response curves here, these ones didn't plateau either, but we could get that economic optimum nitrogen rate. And the control is the gray line, the red is that biological treatment. And you really don't see a difference here. The gray line's, a little higher, but it wasn't statistically significant, probably just due to some field variation. And that economic optimum nitrogen rate was basically right on top of each other. So we didn't see any benefit in yield or in nitrogen from that biological treatment in this trial and in any of the other ones. I don't need to show you 100 graphs that look like this, but they're very similar. Okay, so now you're thinking, oh, awesome. So there's 4 projects in the first cycle of the program. No, we actually had a lot. These projects are super intensive, a lot of research. You might be thinking, who would want to do this? Well, we actually had 38 funded projects now in the first and second cycle of this program. First, grants were awarded March of 2023. I started January 2023, so this is a very new program, but it's gaining a lot of traction. I think people are seeing the value of this more regionalized local data that is conducted from their fields or their neighbor's field. I think you're just able to get a lot more buy-in, and because it's farmer-driven questions. So we have 77 trials implemented across the state. Again, some of those projects have more than one producer on them. So 77 trials across the state and kind of grouped together. We've got some specialty crops, cranberries, potatoes, sunflower, some forages. Then we have that's the yellow dots on the map. We have the core nitrogen rate trials, with like an additional management factor. So those are the ones looking at something like cover crops or manure. And then we have those core nitrogen rate trials, just like that first example I showed you. And we span 33 counties right now with our trials, and we've had over 30 outreach events where NOPP has been a topic at them, or we've talked about them at the event, or they've been at the NOPP field site. So it's been really exciting to get out and talk about what we're seeing from this program. And I think there's one of the more interesting things, there's no one size fits all approach. You might have looked at that first field map and said, that wouldn't work on my farm. I don't have any fields big enough in my county for that. But we're really able to work with you if you've got irrigation and you've got some nitrogen going out through fertigation. We're able to work with you to make this project work. We want to span geographically all the regions. We want to get as many management practices in this program as possible. So we're really able to work with you and get this working on your farm. One of the questions I get, okay, all these projects look different. You have 77 different trials, 77 different trial designs. What the heck are you going to do with all the data? How are you ever going to gain something, across the board? But we do have a lot of things that are collected across all projects across the board, no matter what the projects look like. So this is just a yield response graph. Again, applied nitrogen, so that's all of the trials in the state from last year, all the different nitrogen rates they had, and then all the yield points. So this is kind of like a yield response curve with everything. And you can see super clear trend here, right? Super easy to parse out what that optimum nitrogen rate would be, right? No, right? Nitrogen management it's difficult. There's a lot of nuances in it. And kind of one of the cool things, because we have so much data and we have so much background information on this data, is that we can parse out what's the difference between the fields that we're yielding here at night at 0 pounds of nitrogen per acre versus the ones that we're yielding up here at that 0 rate. So as we continue to work as we continue to work with the data scientists on board, we're going to be able to parse some of these things out and hopefully make some conclusions as we continue to do these projects and collect data. And another thing from these trials, like I said, we're able to get that economic optimum nitrogen rate, and we also have the university rec for these sites as well because we have that background data. So here's a graph of graphing those two against each other. So we have our university rec on the x-axis, so that's kind of like the predicted what that optimum nitrogen rate would be versus the economic optimum nitrogen rate from trials that actually happened last summer through the NOPP. So it's kind of like the predicted versus the actual. And if it were a perfect model, and if our university recs were right on the money every single year, no matter the weather, we would have all those dots landing along the line. That the predicted would equal the actual, but that's not the case. It was the case at 3 sites, so Good. That's great. Good start. But we want to figure out how we can try to make those university recs better. Maybe we're underestimating manure or overestimating soil nitrogen credits. How can we get those dots closer so that we're applying nitrogen closer to what our actual optimum is? So I know after I've just rambled at you for half hour, you're like, I need to find out more about this project, right? More about this program. So this QR code will bring you to the Crops and Soils NOPP webpage. There we have our our year one report from the first cycle of the program, which just kind of gives like a high level overview of what we saw there. We also have all these NOPP spotlights. So every project that was funded is kind of highlighted in one of these spotlights, and it just kind of gives some farmer quotes about why they wanted to be involved, how they got to be involved. And it's really interesting. It's great to hear those stories. And then this is the same QR code, so it's going to bring you to that same web page where you can find all this information. But we have future NOPP events. We got a lot going on. We're trying to get as much involvement in this program as possible. So that application is set to release in mid-October, so in a couple weeks here, coming up quickly. And then December, we have a UW pre-approval deadline, and that's just coming to me kind of with a project idea and a project plan that's somewhat fleshed out. It doesn't need to be anything formal in writing. That can be as easy as a phone call, just so I know you've thought through how you can make this work on your farm. And even if you haven't thought through, give me a call. We can think through it together. And then applications are due in January, end of January. We also have these brainstorming sessions across the state that my counterpart, Lindsay Rushford with Extension, kind of came up with. So we're having these kind of drop-in sessions if you want to find out more about the program, if you just want to talk about nitrogen, about needs for nitrogen research. These are a great opportunity to do that. And then we also have office hours every Monday starting October 14th from 9:30 to 10 on Zoom. And you can just jump on if you have any quick questions, talk to one of the NOPP staff about how to be involved, or if you have any questions about the program or putting your application together. Or if you're a grantee and you have questions about getting reimbursed or something, it's just a good opportunity to get in contact with us. And this is our kind of our team for NOPP. Lindsay, as I mentioned, she's the outreach specialist with NOPP. I'm the research director, and then Susan Mockert on the programmatic side is the program manager with DATCAP. So all of us, or one of us will always be in those office hours. And you can find all of our contact information again by scanning this QR code. And on the Crops and Soils page, there's a link that'll bring you to the DATCAP page, and that's where the application and everything will be posted. And I think Lindsay's going to drop those in the chat as well. That's all I've got.